If you heard about real-time data and streaming applications, chances are you might want to learn about Apache Kafka. In this video, I will be explaining about what Apache Kafka is and some fundamental concepts of Apache Kafka. So, we will learn history of Kafka, when was Kafka developed, what Kafka really is, how were companies dealing with streaming data before and what changed after Kafka was developed, some Kafka terminologies, 5 major Kafka APIs, and we will wrap up with a summary. Kafka was originally developed by LinkedIn and was subsequently open sourced in early 2011 and currently maintained by a private company called Confluent. Jake Krebs, together with co-founders Neha and June, started working on Kafka in 2008 while they were all LinkedIn employees. Jay chose to name the software after the author Franz Kafka because Kafka is a system optimized for writing and he liked Franz Kafka's work. So, if you have not heard about Franz Kafka, he was a German speaking novelist and a short story writer. Now, you may ask what was the problem they were trying to solve that led to invention of Kafka? Initially, the problem they were trying to solve was dealing with continuous streams of data. But working on this initial idea helped them to understand the importance of improving 3 key areas that made Kafka special. The first one was building Kafka as a modern distributed system. Distributed systems are easier to expand and operate as a service. Another aspect was storage. Messaging systems act as dispatchers of information. But what happens if some recipients cannot receive their messages? You can't expect every system to be running at every moment. And yes, systems are offline. Their messages needed to be kept in store until they can receive them. And then, of course, the streaming model, the continuous flow of messages. Existing messaging systems in the industry were not very well set up for all these, so Kafka was developed. What is Kafka? Apache Kafka is an open source distributed stream processing platform that allows for the development of real time publish subscribe messaging system and event driven application where all new records are immutable and appended to the end of the log. Now, this leads us to ask questions. How were the applications made before streaming concept was in place? Why do we need Kafka now? Let me try to explain this with an example. Say you are working for an e-commerce company and your current architecture is designed for order management and checkout process. In this case, there are multiple integrations written where we have a process that reads the orders and writes them in a queue for checkout. Once the checkout happens, you have synchronous systems that fires up such as shipment and payment, etc. Plus, you also need to write integration separately for asynchronous process such as customer invoicing, fulfillment, and email receipts. Over the time, as the demand grows, we continue to expand and build a number of downstream processes that consume these updates. As you can see, each of these services are reliant upon each other. The problem is that our servers are now struggling to handle the load. The queue is hosted on one server, which is running out of memory and processing capacity. So we now start thinking how we add more computing power by distributing our architecture. This is where Kafka comes in. Kafka is decoupling system dependency. So all hard integration goes away and instead the checkout process broadcasts the events. The other services subscribe to checkout process and choose to listen to that one and they get the information they need and it triggers them to act accordingly, which is why Kafka is a distributed system. The downstream process doesn't have to run all the time but still needs to receive the messages and should be able to handle continuous flow of messages. This naturally helps us understand 3 key areas we discussed earlier, which is building distributed system, storage capability even when other systems are offline, and handling continuous flow of data. It's time to learn Kafka terminologies before we proceed further.
Using our previous example, we have a process which reads the checkout updates and writes down in a queue in Kafka. We call it producer. A number of downstream processes that consumes these updates are called consumers. When multiple checkout happens, there are streams of messages or events sent to Kafka. In Kafka, each one of these queues is called partition, and the total number of partition is called partition count. Each server holding one or more partition is called a broker, and each item in partition is called a record. The field used to decide which partition the record should be stored is called partition key. It's up to the application to decide which field to use as the partition key. If no key is specified, Kafka simply uses random partition. A grouping of partition handling same type of data is called a topic. In order to identify each record uniquely, Kafka provides a sequential number to each record. This is called an offset. Essentially, a record in a topic is identified by a partition number and an offset. One important concept in Kafka is that consumers are very lightweight and we can create many of them without affecting performance. Also in Kafka, each consumer belonging to same consumer group has consumer ID. Multiple consumer groups are useful when we have different applications reading same content. There are 5 major APIs in Kafka. Producer API, which permits an application to publish streams of records. Consumer API permits an application to subscribe to topics and processes streams of records. Connector API executes the reusable producer and consumer APIs that can link the topics to the existing applications. Streams API, this API converts the input streams to output and produces the result. And finally, admin API is used to manage Kafka topics, brokers, and other Kafka objects. In summary, Kafka is distributed. When we say distributed, it means that it runs as a cluster that can span multiple servers or even multiple data centers. The records that are produced are replicated in partition in such a way that allows for a high volume of users to use applications simultaneously without any lag in performance. It has high throughput, highly scalable, and fault tolerant, which means that with Kafka, large scale repetition becomes feasible. Kafka also makes replaying of events easy as messages are stored on disk and can be replayed anytime. Kafka guarantees the ordering of messages within one partition, and it provides an easy way for building scalable and fault tolerant applications. Kafka also provides back pressure, which means that Kafka consumers pull messages from the brokers that allows for buffering messages for as long as the retention period holds. The actual differences between Kafka and standard JMS systems like RabbitMQ and ActiveMQ are that Kafka consumers pull messages from the brokers, which allows for buffering messages as long as the retention period holds. But in other JMS systems, messages are actually pushed to the consumers instead. Pushing messages to the consumers makes things like back pressure really hard to achieve. So, the items sent and received through Kafka requires a distribution strategy, which means that we cannot randomly distribute the content on the queue. We may have to specify a way to distribute, such as an order ID, so that if there are any updates to a specific order, it refers to the right match case. I hope this video was helpful. We have series of videos that you might find useful. Subscribe to our channel to learn more on data engineering concepts.